Okay, the second half, our B video, is going to be really short, but it's really, really important that we know those properties that we were using yesterday, because we're going to use them now to solve equations. And that's going to be super important. Things like this could even pop up on the ACT or SAT for you. So this first one, we note first of all that they all have the same base. It's super, super important that they all have the same base. All right. Next thing is that we're going to start taking these properties, and I've still got them right here on the same page. They're all boxed in. We're going to take these properties, see how well they apply to the equation that we've got in front of us, and just start applying the equation. Or I'm sorry, start applying the properties. So this one that we've got right here, over on the right-hand side, you've got two separate logs with addition in the middle. If you have two separate logs with addition in the middle, it looks just like this right here. Okay, so what we're going to do is we're going to take the left-hand side that we currently have, and we're going to write it like this. Okay, so my two separate logs with their two separate things on the inside, I'm going to multiply those two pieces together and make it look like this. So that is what I'm doing first down here. So I'm going to leave this as 2 times log base 7 of x equals, and then this is going to be log base 7 of, I can now multiply the 27 times the 3. Okay, so a couple things to clean up there. What is 27 times 3? Well, it turns out to be 81. So this right-hand side is now log base 7 of 81. Now that's not something that we should know, because remember, it represents the power that I would raise 7 to in order to get 81. And 81 is not a power of 7, but it's not supposed to be. That's not the point of these equations. Next thing I'm going to do is take a look at this left-hand side of the equation, and notice it actually matches with this property that I have right up here. I've got a number right in front of a log expression like this. So what this tells me is that I can write it like this. I'm going to take this number out front and move it on the inside as an exponent like this. So this 2 out front, I'm going to move it in as an exponent. So my left-hand side is now log base 7 of x to the second power. So I use my third property, the power property, to take this, move it on the inside so that it looks like this. Okay, so now notice I've got log base 7, I have log base 7. So this piece and this piece are now exactly the same, but I have these two different insides. I have x squared on one side and I have 81 on the other side. That's a good thing. Once I get it to the point where I only have a single log expression on the left, a single log expression on the right, and they're the same log expressions, now I go back to what I was just doing in 7-4, I believe, when I was solving these equations. Now, if these two things are true, it must mean that the insides are equal. So all I have to do now is just set x squared equal to 81. And then I solve. So I solve this by taking the square root of both sides. Whenever you're solving equations, don't forget your plus or minus. And the square root of 81 is 9. And we're going to check to see what I can or cannot plug back in here. So if I wanted to plug 9 back into the original, that would be fine. If I wanted to plug negative 9 back into the original, that would turn out to be an extraneous solution, because remember, I have a restricted domain. I can't plug negative numbers into a logarithmic function. So as it turns out, the negative 9 is extraneous, just the positive 9 would work. All right, and we can always do a calculator check, just like we're able to do with so many other equations. So what you're going to want to do is take the 9, store it in for x, and then just type in this equation exactly the way it's written. So 2 times log base 7 of x is equal to log base 7 of 27 plus log base 7 of 3. Oh, and it comes out to be false, of course, because it's doing approximate arithmetic. If you ever see any sort of flag like that, it says it's obtained using approximate arithmetic. So let's try this. Let's try just typing in the left-hand side and see if they come out like really, really close to equal. So if we do that, we get this. If I type in just the right-hand side, I'm going to show that they're just about identical, because our calculator wants them to be perfectly, perfectly equal, and that usually doesn't happen with arithmetic. So look at that. The left-hand side and the right-hand side, as far as I can tell, look identical. It's trying to do these crazy things with rounding and things like that. So if for some reason you do get false, but you get this weird little flag, I'm actually glad this popped up so I can show you this. Just type in the left-hand side, type in the right-hand side, and show that as far as you can tell, they do come out equal. All right, so that one works. We've got x equals 9. Remember, the negative 9 was extraneous. And we're just going to look at one more here. All right, so this one, see how I have this 4 out front? I'm going to use that property where I bring it inside as an exponent. So that's the first thing I'm going to do. Log base 2, this will now be x to the 4th. And then minus log base 2 of 5. So that's really the only change that I've made right now. Next thing is this division right here. I have a property that tells me that if I have division, I can rewrite it. Let me flip here. I can rewrite it as a quotient like this. So if I have log base A of something minus log base A of something, I can take those two insides right here and write them as a quotient. So that is exactly what I'm going to do with this one. I have the same base, so I'm just going to write log base 2, and then I'm going to combine these two as a quotient. So I will have x to the 4th over 5, like this, equals log base 2 of 125. All right, so now I got myself to the point where I have the same log expression. I can just take the stuff on the inside and set it equal. So I'm going to take x to the 4th over 5, set it equal to 125, and at this point it just becomes solving for x, the same algebra that you've been doing for years. So I'm going to multiply both sides by 5, get that x to the 4th by itself, and now I have x to the 4th, and this is 125 times 5, which is 625. And to get x by itself, I'm trying to get rid of this 4th power. So what I do is I take the 4th root of both sides. So you can plug this into your calculator if you need to, but what we're looking for is to see what multiplies by itself 4 times in order to get this, and that would actually be 5. Because this is 5 times 5 cubed, so it must be 5 to the 4th. So this is 5. Double check that you can plug it in here. 5 is a perfectly acceptable input because it's positive. All right, so that counts as our final answer. So I know the video was quick. Just make sure that you're good on your properties and just get lots of practice in solving these equations.